Hello, Year 11. Today we're going to be looking at energy consumption, which is basically your electrical bills or the running costs of different appliances and how we can work that out. So the first thing we need to know is actually that power is measured in watts, which is basically energy over time. So it's measured in joules per second. How much energy is something using every second? But often when we talk about energy, we talk about kilowatt hours. Okay, that is the power times by the amount of time it's been on, and that gives us the total energy that's expended in that amount of time. Now, today's work, you'll need to first answer some questions looking at this energy bill here. So this is the energy bill that will be in your question. And you'll need to interpret it and find some key information. What I'm going to do is just going to show you some key bits, and then you'll be able to answer that question there. So let's look at this first. We've got our energy company, and we've got our name and address. So often energy bills can be used as proof of your address as well. And we've got the amount that they need to pay and when it's due up here on the top. So those are obviously the most important things for someone to know is how much do you need to pay and by when. So that's the summary at the top here. Now, what we have here is the total breakdown of the costs. So you've got the amount payable from their last bill that they've paid, which is showed there. So you can see the last bill amount here was $711.45. And then you've got the electricity bill, you've got the discount taken off. So they had a 5% discount that they were eligible for. And then they had GST added back on, so 10% of the remaining cost, which gives us their total price here. So that's what this kind of section is. It sort of breaks down the costs. You've got here the different average usage of each of from their last bill and then from previous years. So I guess this information is helpful to see whether or not you're using more power than you used to, more energy than you used to, or whether you're reducing your energy. So what this little graph helps you do is compare those things to your last time this year. Obviously, different seasons might have different energy about. So you might use more energy to heat your house if you're in a cold country, or you might use more energy to cool your house if you're in a hot country, depending on the time of year. So in Australia, often if you're running an aircon all day, that's going to use a lot of energy. So yeah, we've got to be mindful of that to not overuse those things. So just be careful of that. Now here we have different energy rates for different times. So if you're running energy during peak times, which is usually around the evening, so just after everyone gets home from work, they all turn on their lights and they might turn on, some things, turn on the TV, use the kettle, all these kind of things. That's peak energy time. And you get, it costs a bit more to use energy at that time. So when everyone's using the energy, there's more demand on the grid, the price goes up. So you can see here the amount of energy that was used in that peak time and the rate here is much more expensive. So that's the total cost of the energy used in peak time. Then you've got shoulder energy, which I guess is like the transition period between peak and off peak, which is a bit less. That's where they use most of their energy, but it's at a cheaper rate, so it actually comes to less than the peak amount. And then you've got the off-peak energy, which is the cheapest kind. So that's in the middle of the night when no one's up, or maybe the middle of the day when everyone's at work. Those would be your off-peak times. And you can see here that's when the rate is the cheapest. Okay, now down the bottom here we have the different months and their energy usage. So you see they're using most of their energy during August for whatever reason that is. It might be that they're heating their house. It might be that they're at home more. They might, for whatever reason. So that sort of breaks it down, as you can see there. All right. So that is basically how we can read an energy bill. Is it has these different rates, these different amounts of energy used. So you see here, kilowatt hours is a measure of energy. It's the power times the time. Kilowatts are just 1,000 watts. So that's usually the unit that we use when it comes to electrical appliances and things like that. All right. Now, the other thing we need to do is we need to be able to calculate running costs of appliances. So we have here, again, powers measured in watts is energy over time, joules per second. But energy, usually measured in kilowatt hours, is the power in kilowatts times the time in hours. Okay, that's how you get kilowatt hours, is you multiply those two things together. So here we have calculate the cost of running a 300-watt television for 6 hours. So the first thing we need to do is work out the energy that's being used. We have the watts, the power, and we have the time. So the energy is just the kilowatts, okay, or in this case, it's just watts times 6 for the hours, and we end up with 1800 watt hours, but we can convert that by dividing by 1,000 to 1.8 kilowatt hours. Okay, so that's the first thing we need to do. You've got to be careful with your units. Are you looking at watts? Are you looking at kilowatts? So just need to convert there to make sure that you've got it in the right units, so that when you do the second part here, where you calculate the cost, you're in the right units. You see it says cents per kilowatt hour. So that means our energy needs to be in kilowatt hours for us to do this calculation. So the cost, once we've found the energy, is going to be this energy 1.8 times the cost here, which is 47.77 cents. We're going to put that in our calculator. We get 1.8 times 47.77, which equals 85.986 cents. Now to the nearest cent, this equals 86 cents. Okay, so if you run your television for 6 hours, it's going to cost you 86 cents, which is not a lot of money. But obviously, you know, all of these things add up together. Your television relative to other appliances would probably use a bit less electricity. Something like an oven or your aircon will use a bit more. Anyway, good luck with the questions today. Let me know if you need any help, and I'll see you in the next video.